Hello everyone and welcome back. My name is Mr. Koval, and in this video we're going to continue with identifying redox reactions, but we're going to also go over how to identify the reducing agent and the oxidizing agent. And so one of the things you may have noticed by now when we're talking about redox reactions is that if you know that reduction is the gaining of electrons, like remember oil rig. So oil is oxidation is loss of electrons, and rig is reduction is gain of electrons. So if you remember that, then if you know that reduction, oxidation is where you lose the electrons, then those electrons have to go somewhere. They can't just float away, right? So if you have something that is giving away electrons, then there's also got to be something that's taking those electrons. So if something is being oxidized and losing those electrons, then another thing has to be gaining those electrons and being reduced. So the two processes go on simultaneously. They're together. They don't happen by themselves. So if you are giving electrons away, then something is taking them. So reduction and oxidation happen together. So if there is reduction going on, then there has to be something doing the reducing, right? So that's what we mean by an agent. An agent of change is something that causes change, right? So if you are a reducing agent, then you are something that is doing the reducing, right? So if you're doing the reducing and you're causing something to be reduced, right? So if you're causing something to be reduced, mainly you're causing them to gain electrons. Well, how are you doing that? You are giving them the electrons, right? So if I am the reducing agent, I'm going to cause them to be reduced by giving them electrons, right? But what happens to me when I give the electrons? I'm losing electrons. So that means I am being oxidized. So the reducing agent, the agent that does the reducing, that reduces something else, has to lose the electrons and become oxidized. So the reducing agent becomes oxidized because in the process of reducing something by causing them to gain electrons, that thing is losing the electrons at the same time. So the reducing agent is getting oxidized. So what happens, what do we call the thing that is now taking the electrons, right? So what about the oxidizing agent? The oxidizing agent is the same thing. It's the oxidizing agent is that which is doing the oxidizing. So if I am an oxidizing agent, I'm going to oxidize something else. I'm doing the oxidizing to something else. I'm not doing it to myself. I'm doing it to something else. So the oxidizing agent is the agent that causes something to be oxidized. And so what is oxidation? Oxidation is loss of electrons. So how am I going to cause them to be oxidized? Taking their electrons, right? So if I take the electrons as the oxidizing agent, I'm going to take your electrons. So now you're oxidized, you lost your electrons. What happens to me as the oxidizing agent? I gain the electrons, so I am reduced. So the oxidizing agent is reduced. So whatever the oxidizing agent does, or whatever the agent does, the opposite happens to the agent. So if the reducing agent is reducing, then the reducing agent gets oxidized. So whatever gets oxidized is the reducing agent, or whatever gets reduced is the oxidizing agent. So the opposite happens to the agent. Okay, so I'm hoping that clear. I know that can be hard to understand and kind of confusing, but remember that idea of the reducing agent is the one that causes the reducing in something else. And then if reducing is gain, well, I'm going to cause you to gain electrons. How do I do that? I'm giving you electrons. But in giving you electrons, I'm getting oxidized, right? So that's why the opposite happens to the agent. So let's go over this. So I have three examples. We're going to find the oxidation states, and then we are going to decide what's being reduced and oxidized, if anything, and then we'll go from there. So the first thing we want to do is oxidation state. So I'm going to go over this fairly quickly. So this is a free element, so the oxidation state for free elements is 0. This is a free element too, so the oxidation state there is 0 as well. That's rule number 1. And here we have an ionic compound, so now we're going to assign oxidation states. Here I have a metal, and the metal here is a group 2 metal, and so we're going to do that one first, and that's going to have an oxidation state of a +2. And so in order to balance this, according to rule 3, the overall oxidation state should equal the overall charge, which is in this case 0. So if I have a +2 here, then the one oxygen has to have a -2. So now looking at this, I look at the oxidation states, and I can determine what got oxidized, where the oxidation is occurring, and where the reduction is occurring. So the magnesium goes from 0 to +2. So to go from 0 to +2 is an increase in your oxidation state. So to increase positively means you're losing negative electrons. So if you're losing electrons, that is going to be oxidation. Okay, so oxidation is occurring with the magnesium. What about the oxygen? We go from 0 to -2. So there, we're dropping down in our oxidation state. So there we are gaining electrons, and reduction is gain. So here we have reduction. So the oxygen is being reduced, the magnesium is being oxidized. So now that we figured out where the oxidation and magnesium is occurring, or the oxidation and reduction is occurring, now we can figure out what the oxidation and reduction reagent is. Now let me specify this. Reagent. The word reagent refers to reactant. So we're only looking at the reactants. We're not looking at product. So which of the reactants is the reducing agent? So remember, whatever agent you are, the opposite happens to you. So if I'm the reducing agent, then I'm being oxidized. So what got oxidized? Magnesium. So since magnesium got oxidized, this reagent got oxidized, then this is the reducing agent. And so I have two reactants, so if this is the reducing agent, then that must be the oxidizing agent. And we can see that because oxygen got reduced. So if oxygen got reduced, that means it is the oxidizing agent. Okay, and that's it. And that makes sense because oxidizing agent, oxygen, so it makes sense that oxygen would be the oxidizing agent. Okay, let's go on to number 2. So here, let's do our oxidation state. So here we have hydrogen and bromine. This is an acid. So bromine is in group 7. So that's going to be lower on the table than hydrogen. So we'll give hydrogen first. So according to the rule, that gets a +1. And then to balance the oxidation states, since it's a 0, that's a -1. Calcium, this is a metal. It's a group 2 metal, so that's going to be a +2. Hydroxide, that's an overall charge of a -1. So hydrogen is higher on the table, so we're going to assign a +1 to that first. And so to get the -1, oxygen has a -2 oxidation state. So that gives an overall -1 for hydroxide ion. Okay, moving on to oxygen. So hydrogen is higher, so we're going to start by giving hydrogen a +1 charge. And so we have 2 hydrogens, so that's a +2. To balance that, because the overall charge is 0, so we need a -2 oxidation state on the oxygen. And then here we have, again, calcium and bromine. Calcium is a group 2 metal, so that's going to be +2. We assign that first. And then the group 7, we assign that. And so we need to balance the charge. So this is +2, we need a -2. So that means a -1 oxidation state for each of the bromines. Now we look at the oxidation states and see if there's a change. So we have a +1 hydrogen, +1 hydrogen. -1 bromine, -1 bromine. +2 calcium, +2 calcium. -2 oxygen, -2. And then we have +1, +1. So there's no change here. So this is not a redox reaction. Not a redox reaction. Not a redox reaction. So we can skip that one. There is no oxidizing agent or reducing agent. All right, let's try this one now. So this is a free element. So that's going to be a 0 oxidation state. This is a free ion. So the oxidation state, according to rule 2, is the same as the charge. So it's a +2 oxidation state. Notice that the +2 oxidation state, 2+ charge. Okay. Now here we have zinc. That's going to be a +2 charge. So again, the oxidation state is the same as the charge according to rule 2. And then again here we have an element, no charge, so 0 oxidation state. So we can look here really simply, really quickly, that zinc goes from goes from 0 to +2. Okay, and that means it went up in oxidation state, so it's losing electrons. So oxidation, so it's being oxidized. Oxidation is occurring. And then once again, if we look here, we have iron going to from a +2 to 0. So it's going down in oxidation state, so it's gaining electrons. So this is your reduction. That's what's happening here, reduction. And so now that we've identified where the reduction and oxidation is occurring, now we can figure out what our oxidizing agent and reducing agent is. So remember, if you're a reducing agent, you are getting oxidized. So what got oxidized? The zinc. And we're only looking at the reactants, right? So the reactants are the reagents, not the product. So we're not looking at the product, we're looking at the reactants. So the zinc got oxidized, so this is the reducing agent, because the agent does the reducing, but the opposite happens to the agent. So it gets oxidized. And then the other reactant, since we only have 2, that has to be the oxidizing agent. And so we can again see that the iron 2+ is got reduced, so that must be the oxidizing agent. So here, let me circle this, and it's Fe2+, not Fe. Fe2+ is the reagent. So this is the oxidizing agent. Okay, so that's how you figure out oxidizing agent and reducing agent. Remember, if you're the reducing agent, you're getting oxidized. So if you can find the oxidation, then you can find the reducing agent. And the opposite is true for the oxidizing agent. Right? So the oxidizing agent gets reduced. So if you can figure out what got reduced, then that reactant is the oxidizing agent. Okay, I hope this is helpful. If you have any questions or comments, put them in the comment section. Like this video if you like it, share the video, subscribe to the channel, and hit the notification bell so that way you'll be notified by any other videos I put out. Thank you for joining me, and I'll see you next time.